Hello everyone, my name is Dora Beranic and my mentor is Dr. Branko Mihajlovic. I'm a junior student in Web and Mobile Computing undergraduate program at our IT Croatian Zagreb campus, and today I will be talking about the new implementation of structured concurrency in Java Virtual Machine developed initially within the OpenJDK's project Loom. In this presentation, we will look at current implementation of concurrency in Java and state all the drawbacks it has. Then I will introduce you to the concept of structured concurrency and its benefits. Lastly, I will tell you something about Project Loom and the new implementation of threads called virtual threads, also known as fibers, their comparison to threads, performance, and future development. In the current implementation of the JVM, threads are the core abstraction of Java's concurrency. However, Java does not have its own implementation of threads, like for example Python, and therefore heavily relies on operating system kernel threads. This makes their creation costly, a few megabytes, their scalability low, and execution of operations expensive regarding memory usage. In server-side programming in Java, most common model is thread per request model. This model requires the creation of many threads, which makes these applications inefficient in performing input-output operations because of constant blocking that occurs each time a thread is waiting for a resource. The dependency on operating system threads also limits the maximum number of requests and therefore requires an improvement. The core concept of structured concurrency is that each time a control splits into multiple concurrent paths, they join up again. This means that several concurrent tasks can be executed in the same time by swapping threads. However, those threads have to terminate before the main task is completed. The color of the method is not concerned with how many threads are used to execute a task, which improves the readability. But when the method completes, all threads scheduled by the method should have terminated. This gives us much higher level of control, and threads are unable to outlive their tasks, which gives us much better control flow. So, Project Loom is an attempt by the OpenJDK community with a goal to integrate a lightweight concurrency construct into Java. The key concepts introduced by Project Loom are continuations, fibers, and tail call eliminations, integrated into native JVM construct. With their new implementation of the JDK, Project Loom presents a concrete implementation of structured concurrency in Java. There is no scheduled release date yet, however, we've tested and compared the performance of fibers and threads on an early access build, which is currently hosted on GitHub. So first, I will tell you something about continuations. Continuations or coroutines are a sequence of instructions that run until they are yield or completed. In the Project Loom, we're presented with delimited continuations, which have entry and yield points. Yield point is where continuation was suspended. After they're resumed, they continue running from yield point. They are a low-level construct implemented in the JVM and are used for building higher-level constructs such as fibers. In this implementation, suspend and resume occurs inside Java runtime instead of the operating system. Therefore, it prevents switching between kernel threads, which is expensive in regard of memory. The goal of Project Loom is to support nested continuations, also known as sculpted continuations. So finally, fibers, also known as virtual or user mode threads, are a new implementation of threads created by Project Loom. They're created inside the JVM and rely on Java runtime implementation of continuations and schedulers instead of the operating system's implementation. Fibers exist inside the JVM and are only mapped to the operating system threads when they need to perform a certain task. For example, if a fiber is waiting for an input-output operation and is paused, it releases the operating system thread, which can then be used by another fiber. Being managed by the JVM makes their creation, swapping, and blocking much cheaper than with threads who are mapped to the operating system threads since their creation until being swapped by the garbage collector. Here you can see the example of one of our tests. So we created a simple HTTP server to whom we are sending Go Tigers message. After receiving the message, the server waits for 10 milliseconds, which presents a certain task which lasts 10 milliseconds. We run the same server with both fibers and threads and compare their performance under heavy load, which is 60 requests per second in the time period of 8 seconds. Here is the same code example with fibers. In this implementation, they are created inside the fiber scope, and same as threads, execute a runnable task and wait for 10 milliseconds. Now I'm going to show you the demonstration of previous two code examples. Okay, now I'm going to show you the demonstration of one of our tests. So here you can see the simple HTTP multi-server implementation with threads, and here is the implementation with fibers as shown in the code example below. Now we are going to run the code example with fibers and test the latency period. Okay, so now we will launch a Vegeta attack on this fiber server and see what the test results are. So the attack lasts 8 seconds and attacks with the rate of 64 requests per second. And now we will see the graph results. As you can see below, the fibers have the latency of around 5 milliseconds, and this spike here is created because of the garbage collector. Now we will run the same test with threads and see what the test results are. First, we will stop the fiber server and start the one that is handling the requests with threads. They're both sending Go Tigers message. Okay, now that the server is started up, we will run a script for the second attack. Wait 8 seconds, and then the test was successful, and we will see the results. We have to make them a bit more clear, but as you can see from these results, the fibers have the latency of 5 milliseconds, while the threads have the latency of more than 40 milliseconds, and therefore we can conclude that in this test, fibers outperform threads by more than 8 times. And as well with fibers, these bigger spikes, they're created because of the garbage collectors. Okay, now we will go back to the presentation. In the new implementation of Project Loom, we will use virtual threads instead of fibers because they're trying to adapt to the current implementation of threads or Java Long Thread API. This change is present in JDK 16, which is available as an early access build. However, this build is still experimental and currently has some difficulties with building the JVM. Secondly, after the stable release of virtual threads, we will be introduced with the first implementation of tail calls. For the conclusion, I would like to say that based on our test results, fibers look promising. They outperform threads in certain tasks by more than 6 times as seen in our demonstration. Being managed by the JVM makes fibers more independent from operating system threads and more Java-specific, which significantly increases their performance compared to threads. They can also withstand heavier load under which threads tend to crash. We are looking forward to their new implementation and to their release in production. Thank you for your attention.